Okay, good morning. Um, we are coming here together to talk about light vehicle emissions basically, and I will give you a brief introduction. My name is Niklas Schmalholz from POLIS Network, and we are the communication partners of the LENS project. LENS stands for L Vehicle Emissions and Noise Mitigation Solutions, and the general information about the webinar is that if you have any questions, please state them in the chat. Um, maybe not all of these questions are going to be answered, but in case you have further questions, feel free to contact Polis or the presenters afterwards. And I will try my best to upload this webinar on YouTube, on our LENS YouTube channel as quickly as possible, and also provide a summary on the LENS website, where you will also find a link to the recording in case you would like to know more, and the slides that we are presenting here today will also be included. Because I'm the communication manager, this is my duty to share with you all of our channels. So we have our website, lens-horizoneurope.eu, and we are also on Twitter and LinkedIn. Today, we will talk a bit about LENS in general, which will be done by our project coordinator. And then we talk about the background information about the lab tests by IDIADA, and of course the real-world driving test as well. And then we will talk about some preliminary outcomes of the L vehicle tests, which will be presented by our colleague from TU Graz. And then I will come back to you and talk about some upcoming events and communication. Basically, if you have questions, state them in the chat and I will read them out to our presenters after each presentation, basically. So now I will give the floor to our project coordinator, Leonidas.
Yes, thank you very much, Niklas. It's great to be here, and thank you for your interest in our project. So I am sharing my screen with you. I hope you can see. My name is Leonidas Diakristos. I am professor of mechanical engineering at Aristotle University of Thessaloniki, and I coordinate this project on behalf of our spin-off company, EMISIA. The project has been funded by Horizon Europe. It's a research and innovation action. We have 15 partners and total budget of 5 million euros. Here you can see the partners of the consortium. EMISIA is the coordinator, and then we have a number of testing labs. IDIADA in Spain, Graz in Austria. They are going to speak to you after me. And then together with the other laboratories and research institutes, we also have the pleasure to have with us 4 OEMs, KTM, BMW, Ducati, and Piaggio, and also Horiba as an instrument manufacturer. Very shortly, I think all that we are here, we have an interest both in the noise and the emission from motorcycles, and you can see here different excerpts from press on how annoying motorcycles are because of noise, and also some research works on what is the contribution of motorcycles to air pollution. I guess we're all aware of this issue, so I'm not going to spend more time on that. Just to say that, you know, if emission standards deliver what they are supposed to deliver, then we should be looking at significant decreases in hydrocarbons, CO, and particulate matter for motorcycles, and NOx also, but NOx might not be decreasing as substantially. Euro 4 was already maybe not so far with Euro 5, but those questions are among the questions we want to address in the project. And my colleague Stefan Schmidt from TU Graz is going to discuss about that. Now, what I want to say is that emission standards might not be efficient over complete operation conditions. Here, for example, you see a very high CO event, high speed of a motorcycle. So we also have to address conditions that go beyond the driving side. To do that, we want to try and test emissions from motorcycles under different conditions. And for that, we had to develop different emission techniques. We had to identify infield tampered vehicles and also the performance of motorcycles and mopeds in the real world, and then synthesize all of these data to produce recommendations for policymakers. And in a nutshell, I'm only going to show you some pictures. We are conducting in-lab measurements, on-road and test track measurements. We are also remotely measuring emissions from motorcycles. We synthesize all of this information to update the most common models that you know in Europe about noise and emissions. And then we do different impact assessments in specific locations, but also around EU. And we provide, as I said, also for recommendations to our policy. So just a snapshot of what I have been describing to you. We are conducting laboratory tests according to the type approval conditions, but also going beyond type approval in the lab on a chassis dyno that it is available in different labs of the LENS project. We are also conducting on-road measurements for noise and emissions. I'm going to show you later on. And as you can see, we are looking into all of the categories of subcategories of L category vehicles as much as possible. We are also doing on-track measurements, especially when we need to measure noise away from other noise sources. Then the track is a very good condition, and IDIADA and IDIADA have provided test tracks for that. And as I told you, we have also been developing quite small-sized sensor-based measurement system for emissions that we can carry on the different vehicles, and we can conduct emissions on the road. Finally, as I told you, we have conducted what we call remote sensing. Basically, I guess most of you know these tests, vehicles passing by, and then we have different monitoring instrumentation in terms of noise, in terms of pollutants concentration, and we can observe instances of emissions as the vehicles pass by. And in that way, we can also detect high emitters on the road. I think, and this is where I'm going to stop, we are providing evidence for effective policy. We are developing devices and methods to monitor emissions and noise in the real world, and we are calculating cost-benefit scenarios. The project ends within the year. The exact date, just because we have asked for a small extension, is not finalized yet, but it will be Q3, Q4 2025. We will have a final conference, as Niklas will inform you. So you're very welcome to follow us in these last stages of the project, where most of the interesting results are going to be. And with that, I would like to thank you very much for the attention. Myself and my colleague Georgios Trelophilos at EMISIA are here at your disposal to help you if you have any specific questions. Thank you.
Thank you very much, Leonidas. Since we don't have any questions in the chat, we will go directly to Alba, because we will have basically lots of detailed content to share. Yeah, don't forget, I'm addressing the audience to state your questions in the chat, so I can read them out, and to clarify, in case we are talking about now the more technical issues, there are probably lots of questions in the chat. Yeah, Alba, I give the floor to you now.
Yes, thank you very much. Good morning to everyone. So I'm going to share my screen right now. So can you see my screen correctly in presentation mode?
Yeah.
It's perfect. So
yeah.
Thank you very much. My name is Alba Garbi. I work for IDIADA. So I am a senior engineer at IDIADA, and I am related to projects related to sustainability, energy efficiency, and emissions, and exhaust emissions. And I'm involved in other European initiatives, And from when I started my background at powertrain department, my main activities were related to on-road testing for RDE and also PEMS, so light duty and heavy duty. So yeah, I'm going to provide you an overview and background of the LENS project. So why we are here, why all this, what is the framework of the LENS project, and why are we doing these measurements. So first of all, I will provide you an explanation of the L category vehicles. What are these kind of vehicles, their subcategories and special characteristics and usage. Also, I'm going to explain about the population of L category vehicles in Europe and the impact in the overall emissions. And finally, a comparison of the exhaust emission regulation of these LVs compared with other vehicle categories, type approval requirements like light duty and heavy duty vehicles. So L category vehicles are much more than just motorcycles, or let's say two-wheelers, but they also cover three-wheelers and even four-wheelers with some characteristics that we are going to see in the following slides. You might see in this table an overview of all the subcategories, which cover from mopeds, motorcycles, tricycles, light quadricycles, and quads and buggies. So let's see that in more detail. So here you can see the L1E and the L2E, which are the mopeds, and are characterized by engines with less than 60 cc for spark ignition engines, a maximum power of less than 4 kilowatt, and what is interesting is the maximum speed. So these are vehicles designed for less than 45 kilometers per hour. L1E are the two-wheelers, and the L2E are the three-wheelers. So here in this table, you can see the most common subcategory, which are the motorcycles. They are classified as A1, A2, A3, the low, medium, and high performance motorcycles. A1 classification is related to the engine capacity of less than 125 cc, and are also limited by maximum power and power to mass ratio. For A2 and A3, the classification is not related to the engine speed, but the power and the power to weight ratio. A2 have a maximum power of 35 kilowatt and a power to weight ratio of 0.2 kilowatt per kilogram. So this is what limits A2, so the rest are A3. So L3E also have a special two-wheel motorcycles that are designed for special purposes, are motorbikes designed for rough terrain or obstacles with purpose like endurance and trials riding. So these are classified as E for enduro and T for trial bikes, and also follow the same categorization as A1, A2, and A3. Then we have the L4E that also follow the same characteristics as A1 and A2 and A3. And what makes them unique is that they have a sidecar. They have a maximum of 4 seating positions, including the driver. And L5E are the tricycles, which are the three-wheel vehicles that cannot be covered with the L2E. So it's important to highlight some special characteristics of these L subcategories from L1 to L5 compared to other road transport vehicles. So there is a noticeable impact on the driver's weight in the running order mass of the vehicle that can vary from 25 to 60%. Also, the air resistance is an integral part of the human-machine combination, which implies a high variability in the real running resistance when driving this vehicle on the road. This also might make the engine to work in higher loads or let's say in different engine operation than in control conditions in laboratory testing. So this might have an influence on the exhaust and noise emissions. Also, the high performance engine capacity ratio is another particular characteristics of this kind of vehicles, meaning that these vehicles can develop a high power for lower engine capacities than the other vehicle categories. So let's move then to the four-wheelers that I was explaining at the beginning that are also included here. So we have the L6A and the L6B that are referring to the light on-road quads and light quadricycles, which have in common to be one of these mobility vehicles, so urban mobility vehicles with a maximum vehicle speed of less than 45 kilometers per hour and with low power. So the L6EB are the well-known microcars, and the L6A are the quads. And these microcars are these vehicles that can be driven without the full driving license. So here we move to the L7E vehicles. We have A1, B1, and B2, which cover these vehicles that cannot be classified as L6E. We have the heavy on-road designed for the transport of passengers, and we have the all-terrain quads that are also can be built for the transport of goods, and with a maximum speed of 90 kilometers per hour. And finally, we have the side-by-side buggy with the attribute to have two side-by-side seating positions and are equipped with a steering wheel. So as a conclusion, let's say that LVs cover a wide range of vehicle characteristics and a huge variability in their usage cases. So for instance, as I was explaining, it covers vehicles designed exclusively for urban mobility with maximum speeds of 45 kilometers per hour, and that can be used without a full license. It also covers all-terrain on-road vehicles for rural areas and for RCs, and also medium and high-power motorcycles for road trip, on other purposes and long trips in the highway and higher speeds. So here, with you can see in the right-hand side plot the countries with the largest L category fleet, and also classified by subcategory. So Italy, Germany, and Spain, we have the biggest fleet. We can see in dark blue and in orange the low engine capacity bikes, which represent the biggest share, followed by the medium and high power motorcycles. So related to the usage of these LVs, we might say that the urban mobility predominates. Also young drivers mobility with the possibility to be driving as of 15 years old. And another user profile are the enthusiasts with a more eventual use. Also to stress out about that are more common in the South Europe regions and are used throughout the year, and in Northern Europe are not used in winter period. So tampering assessment is also part of our project. We have conducted more than 600 surveys to LVs drivers from more than 20 European countries. So, and according to the statistics of these surveys, we found that the most common tampering methods that occur in these kind of vehicles are related to the exhaust, with most common modification, the replacement with aftermarket silencer, even removal of the silencer or the catalyst, modification also of the exhaust manifold. We also see as a common modification the aftermarket air intake filter, and software modifications to the ECU. So if you would like to have more information about the result of this survey and the assessment that we have done to the undesirable effects to the exhaust emissions and pollutant emissions and noise emissions. So this deliverable, there is a study, a deliverable result of the project that is available online and in our website, so you are able to access to this document. So about the population, We have the data updated as of 2022. So in 2022, 327 million vehicles are the road transport fleet, and 12% correspond to the L category vehicles. 2% are related to the heavy duty, and the passenger cars and light commercial and basically all the rest. So moped represents 30% of the fleet, and motorcycles with less than 250 cc around the 30%. L6 and L7, so quadricycle, just represented 2%, and the fleet of the battery electric vehicles just 1%. So another representation of the fleet, it's now distributed to the Euro standard. We might see here that we can conclude with this representation of the Euro standard that Euro 3 standard predominates, that there is a few share of Euro 5, so that this indicates low transition to the new Euro stages. Actually, the L category fleet is old compared to other categories, and I think that the fleet of LVs is actually 19 years old. Battery electric vehicles remain a minority, and there is important decrease of a decline of mopeds in the new Euro stages, meaning that the sales of these vehicles have decreased over the last years. This can be by several reasons, maybe because of the new mobility solutions for younger people, or reduce of the difference in price in 50 and 125 50 cc, or the preference of microcars, etc. So one of the purposes of the project is to update the current emission factors of this category. So in order to provide more robust information regarding the impact of the current fleet on the overall emissions, so Copert software shows us that we have a significant impact on CO and hydrocarbons, but not in NOx and particulate matters due to the nature of the indirect injection engines, which are equipped regularly in these vehicle categories. So LVs are responsible of 13% of CO emissions and 20% of hydrocarbons of the whole fleet transport, but just represent 12% of the fleet. And this is even more significant when we consider that the annual mileage of motorcycles is much more lower compared to the other vehicle categories. So the reasons of having this high CO and hydrocarbons is that the age of the fleet, that is old, and also the huge difference between the engine operation points in type approval testing and in real world driving. And this brings me to the next slide, where there is you can see a picture of the summary of the type approval requirements for exhaust emission in the different road transport categories. So motorcycles or L category vehicles are the testing for type approval is done over the WMTC cycle. We are measuring hydrocarbon, NOx, CO, and CO2, and the real driving emissions are not required. And this is one of the purposes of our project, is to develop a procedure to measure emissions on the road and to update the emission factors, covering a more realistic environment. So, and PN, it's not regulated for L category vehicles, and RDE is applicable for passenger cars, for light duty vehicles as of 2017, but actually the origin of the portable emission measurement systems was the heavy duty vehicles that the PEMS testing is applicable of 2023. So next slide show just a summary of the limits, just to highlight that actually for L category vehicles, we just measure CO, hydrocarbons, NOx for pollutants, because actually PM is also mandatory, but it's just for direct injection and compression ignition engines, which are not commonly used in these vehicles. And also to highlight that although LVs are according to Euro 5 and light duty and heavy duty are in Euro 6, so the limits of L category vehicles are the same as for the light duty vehicles Euro 6. But PN is not required. That's the difference. So, and in order to finalize my presentation, and I am going to comment on a special characteristic that distinguish a lot LVs from passenger cars, which is the power to weight ratio. So here is a scatter plot of the power to weight ratio for most common L subcategories compared to passenger cars. So in general, LVs have much more higher power to weight ratio than passenger cars. That's especially seen in L3A3. And so these characteristics is strongly dependent on the subcategory. As you might see here, there is a really huge spread of the power to weight ratio of these characteristics. And that brings me to the next slide, which is that the power to weight ratio it's a construction characteristic that affects a lot of driving dynamics. So here we can see a plot for the driving dynamics that is required in the RD regulation, the product of the speed and the acceleration, which is a proxy of the power and the aggressiveness of a test. And also we can see an engine map. So we see the differences for a passenger car and a motorcycle, an L3E-A3. So we can see that there are much higher driving dynamics on a motorcycle than in a passenger car. So even doing a very aggressive and high power demanding test in a passenger cars, we surpass, we exceed the limits slightly. But on motorcycles, due to these construction characteristics and the power to mass ratio, so the limits of passenger cars cannot be adopted. This is an example on what are the purpose of our project, is also to develop these new requirements for a future regulations of RDE in motorcycles, and even considering the wide spread of different subcategories, also the shares of urban, rural, and motorway driving, and the trip characteristics should be modified and specified by the subcategory. So this would be my introduction. Thank you very much. I'm not sure if there are some questions now.
We have one question which was stated a couple of minutes ago from Federico Vitale. Where were the modifications of exhaust systems with type-approved aftermarket ones considered as illegal or not? So
yeah, that's a very good question. Yeah, of course, not the illegal ones. So when we are talking about the tampering, we are talking about not the let's say the legal aftermarket systems.
Okay. Thank you very much. This was the only question, so I can give the floor directly to Stefan. If you have further questions, yeah, just continue to write them in the chat. Thank you very much, Alba.
You're welcome.
Yeah, thank you. Hello, everyone. Good morning. My name is Stefan Schmidt from the Institute of Thermodynamics and Sustainable Propulsion Systems at the Graz University of Technology. I'm a team leader here and responsible for several research projects, funded research projects, mainly with the focus of two-wheelers and small powertrains, and in this case, responsible for the measurements which have been done conducted at the TU Graz. I will guide you through the preliminary outcome of these measurements, what we have done on the road, in the lab, roadside measurements. I have to stress out that these are preliminary data, so we haven't analyzed all the data what we have collected. You can imagine 150 vehicles, that's a vast data pool. We have to have a deep dig into the data, but several outcomes can be presented right now. So first, what will I show you today? So two different parts, one about the measurement equipment and the methods. So what are the findings, the developments, what we have done. So considering the PEMS, mini PEMS and SEMS, I will explain that later on. Something about the RDE trip composition and synthetic real drive cycles, and then followed by first results of the fleet emission, split in type approval emissions and on-road emissions. As Niklas stated, please give your questions in the chat and I will answer that. I'm happy to answer that afterwards. So starting with the typical type approval measurement method, what we have available for two-wheelers, just a short explanation. I know that some of you are quite familiar with that, but just for the audience. This is a two-wheeler chassis dyno where we have the vehicle on a one-roller chassis dyno placed. You can see on the picture on the right side, so that's a typical setup. We have a CVS sampling system for the exhaust gas, and then we have emission test bench for the analysis of the gases. We have a CAN bus access to get some additional data from the vehicle. So that's the typical setup what we have. What we found out is that we have a lot of restriction for these chassis dyno measurements. So these measurements are made for type approval with standard tests where we usually do not have a lot of high power demand, not a high power demand, not high speed demand. And when we want to write real driving cycles, which we collected on the road on these chassis dynos, we found out that we have typically for the two-wheeler, two big issues. One is we have a big rear wheel slip. This is indicated on the right side, so that's a moving back tire, and we have a big rear wheel slip, so we have restrictions with very high powers there. And of course, we have power restrictions of the standard chassis dynamometer. So the standard dynamometers are meant for vehicle speeds up to something around 140 kilometers. Of course, there are other ones which can make higher speeds, but the typical ones 140. And if you're driving on the road, maybe in open roads like in Germany, you are well over 140. So these are the restrictions. And for the four-wheeler chassis dyno, there are also some restrictions, mainly due to the off-road tires. As you've maybe seen on the road, these off-road tires, they are really not really smooth on the surface. So this brings some difficulties in the comparison. So that means at the moment we have some difficulties with transferring RDE data to the chassis dyno. The next thing what we have for on-road measurements, so that's from heavy duty and light duty passenger car vehicles. So that's the standard equipment, which is called portable emission measurement system. So this yellow, this white box on the top, so that's the emission measurement system. We have an additional measurement system for the exhaust flow mass. The typical weight is something around 60 to 90 kilogram for the available systems, which is mounted on the rear outside of the vehicle and connected to the exhaust pipe. And if you take a look at how this looks on the heavy duty vehicles and on passenger cars, heavy duty vehicle on the left side, so this is from one of our measurements, you see it's nearly vanishing. So it's really small, and this vehicle can be mounted quite well. On the right side, you can see the typical setup for passenger cars. So it's mounted on the back with a connection pipe to the exhaust manifold. So this is the setup, same system set up on a typical motorcycle. So that's a mid-size motorcycle. So it's not a big one, it's a mid-size motorcycle. And you can see it's really dramatic. It's not easy to handle the system. It's 60 kilogram plus, so it's not really suitable for the vast majority of two-wheelers. So what we found out is that the typical commercial available on-road measurement equipment, these are not suitable for all L category vehicles. So it's big and heavy. It influences, on the one hand, driving behavior, stability, of course, and handling an emission. And of course, in a lot of cases, it's a security issue. So it's not suitable for small vehicles. Additionally, we have an issue with the shortcoming length of the exhaust flow measurement system. So the standard EFM, which uses a Pitot principle, shows a high inaccuracy for the small capacity engine. So several issues what we found out. So we cannot just take the standard PEMS equipment from passenger cars and transfer it to the L category vehicles. So what have we done? We adapted and developed new on-road measurement equipment, and I will give you a short introduction what we have done. So basically different PEMS, mini PEMS and SEMS system, EFM systems, and I will have a short sidestep to roadside measurements also. So these are three types of systems what we used. Beginning on the left above side, so this is a very small system from one of our partners. This is a system which collects only CO and NOx, but it's very small. So it's mounted with a very small probe there. So it's between 8 and 30 kilogram. And on the middle, you can see the same system from one of our partners can detect a little bit more different components, not all the components, what we can measure with the standard PEMS, but it gives a good indication. So these two systems are at the moment available for us. So they are in a development status, and they are capable of giving an indication of some components. And we can mount them also on the smaller vehicles, as you can see on the right side. And additionally, we use the standard PEMS, which is a rather lightweight PEMS with around 40 kilograms. So that's a full-size PEMS, but a very small one, which has been given to us for those motorcycles. This is the RTE configuration as we used to measure on the road. On the right side, you can see the setup. So it's okay for driving, you know. So it's 40 kilograms. So that's something considerably below the passenger, what you have typically on a passenger. So it will influence a little bit the driving dynamics, but it's fine for the big motorcycles. It's fine for the small ones. It doesn't work. We additionally connected a CAN bus interface so in order to get OBD data for the extraction of different variables. We have exhaust flow measurements, and of course we have the PEM system with the GPS, weather station, and so on. So that's the typical setup what we used for the bigger motorcycles. And these are, sorry for that, these are a few pictures how it looks like. On an ATV, you see it's quite easy to mount. On the top, you see that's a mid-size motorcycle. Looks good for the big standard PEMS system. And below you can see the two mini SEMS or mini PEMS systems, which are suitable for also the smaller vehicles. At the moment, we do not have a solution for the very small vehicles, the mopeds, the 50cc mopeds, but because for these mopeds, also the small systems what we have available are too big. Additionally, for a lot of these, we don't have an OBD access because it's not mandatory. A small sidestep to the roadside emission measurements. So additionally to the measurements of the vehicle itself, so measurement equipment on the vehicle for just one, we have conducted roadside emission measurements. So that means collecting the emission plumb of the vehicles and identifying gaseous pollutants on the one hand and particulate matter on the other hand. So that's important for organizations who want to detect high emitting vehicles on the roads. So this was done in 3 different locations, in Leuven, in Paris, and in Barcelona. And I will show you a few results from this. So that's additionally information what we gathered. The next thing what we figured out is that we have to define the standard RDE trips depending on the vehicle class. So as Alba explained before, we have different vehicle classes and they have different maximum speeds, different power to weight ratio. The ones are capable of highway driving, the others not, different driving styles. And what we did was that we designed different RDE trips and different real driving cycles for each of these vehicle categories. So it's a big effort, but of course it's necessary. It makes a difference if you have a 50cc moped, which is usually driven in the urban area, or if you have sports motorcycles, which is also capable of doing 180 kilometers per hour on the highway. And now to the results. I think that's the one what you're all waiting for, taking a look at what's the outcome. That's a preliminary outcome, and I've divided in 3 different sections. One, first is a comparison between lab and on-road tests. So to see what's the difference if we're driving a type of test in the lab, real drive cycle in the lab, and on-road tests. The second is average fleet emission of type approval measurements, WMTC and RDC. And the third section is on-road tests. That means results for selected subcategories and emission classes. As I explained before, all of these measurements are analyzed and extracted for a part of the measurement. We haven't done the analysis for the whole group of subcategories and emission classes. So this is the comparison between lab tests and on-road tests. You've seen this picture before. We have done with one motorcycle tests in the lab, RDE and RDC tests. RDC means real driving cycle. That's a cycle which is extracted from RDE measurements and synthetically put together to drive it on the chassis dyno. And then we did RDE and RDE star measurements. RDE star means that's an RDE measurement on the same track, on the same trip, but with a more aggressive driving style. And as you can see on the left side, that's the characteristic diagram. We cover total different areas with the different cycles. So WMTC, it's a rather small area in the back, in the bottom, so just up to around 20 kilowatts. RDC and RDE cycle is considerably higher, and the RDE star cycle uses the whole power map of the motorcycle. This is also reflected in those dynamic parameters, what you can see on the right side. So passenger car limit, that's the dashed line. And you can see the different dots there. So the triangle, which is filled, is the RDE. And the triangle just with the slide, so not filled, that's the RDE star. So considerably higher driving dynamics. And the result in emission, that's really interesting. Please consider this is a high emitting vehicle. So that's just one vehicle. It's not the average fleet, but it gives a good indication what can happen. On the left side, you can see the CO2 values. So for the WMTC, something around 110, RDC a little bit higher, the RDE in the same range. RDE star is higher, of course, because we have a higher power demand of the vehicle. And then the really astonishing one is for the CO. So we have nearly constant or nearly the same CO values for WMTC, RDC, and RDE. But for the real aggressive driving, we have a remarkable high CO value. So that's not typically, that's not standard, but that can happen. NOx, of course, we see a trend As we have a higher demand of power, we have higher NOx for the RDC, RDE star. There, the vehicle is much more in non-stoichiometric operation, so that means NOx goes down. And on the right side, additionally, the particulate number, so SPN10, you can also see an increase of the particulate number. So I think that's a very interesting thing. I have to mention, again, it's not average value, it's just for one vehicle. Now to the average fleet emission. So this is average fleet emission of the Euro 3 or Euro 4 and Euro 5 for the different emission classes in type approval test. As you can see, CO2 increases, of course, with the size of the motorcycle. I think that's clear, it's due to the mass. NOx is going down. That's NOx, CO, and HC is going down. That's mainly due to the increasing technology, so three-way catalyst and so on, what we have with the higher motorcycle classes. And now comparison to the approval test, so to the limits. So for one type of two-wheeler, it's the L3A3, so the big motorcycles above 125 cubic centimeters and the 35 kilowatts. For Euro 3, Euro 4, and Euro 5. So you can see the CO, all of them are way below the limit, going down with the increasing emission status. So emission limits are going down and also the emission status is going down. We can see the same for the HC and basically same for NOx, where we have very low limits, very low values, all of them way below the limit. So these are the legislative regulated emission classes. And then we have additionally the CO2 and the PN. I think PN is quite interesting. PN 10 dropped down considerably from the Euro 3 to the Euro 5. So that's also a real good, a promising value. Now, the fleet emission for the Euro 5, you can see that's the average of Euro 5 fleet emissions. For L1EB to L3A3, same status. So before we just had the big motorcycles, and this is now an average data for all of the motorcycles. So all of them. You can see a drop of COs for all of the motorcycles where we have a high CO limit for the L1EB, same for HC and NOx. That is due to some high emitters. So we found out that within this class of the L1EB, we have very high emitters. So the average is increased due to very rare vehicles which have a really, really high CO-HC value. You can see the NOx value is low. So that means we have a non-stoichiometric combustion. So really considerably below lambda 1. So that brings a high CO, high HC, and high NOx. And this is if we get rid of the high emitters. So totally different picture. You can see this one is the high emitters included in there. We have the high emitters deleted. And now RDE emission average, the comparison between the lab tests and the on-road tests. So for the L3A3 vehicles, WMTC on the left side and RDE on the right side. You can see CO2 on the left. Of course, CO2 is depending on the power. We have higher power demand for the RDE. Therefore, CO2 rises. We have a higher CO and we have a higher NO. So these are on-road tests compared to lab tests. Please be aware we don't have any limits for on-road tests, and it's not easy to compare these two because we have standardized situation conditions on the WMTC. For the RDE, we don't have any definition how to drive an RDE test. So therefore, it's not easy to compare these values, but it's just to have an idea that, of course, for RDE, the values are increased in this case. And there we have two different vehicles. As said before, that we have an issue with high emitters and low emitters. So these in vehicles, the results of these vehicles influence our average data. And I picked two different vehicles. So those are two different vehicles where we can see high emitter for CO2, that's the vehicle 1. We have a rather high CO2 value for the on-road tests for vehicle 1, whereas we have a low or rather low CO2 value for the vehicle 2. The total contrast is on CO and NO. So the vehicle 1 has a low CO value, a low NO value, but a vehicle 2 has a really high CO and NO value. So these are high and low emitters, and that's the thing what I think we have to cope with in the future. So how to get rid of those high emitting vehicles, so to bring the fleet average down. And then a few just results from the roadside measurements. I've shown you before, we made these remote sensing roadside measurements where we have measurement instruments on the roadside and we measure the plumb of the vehicles which are driving by. This is first analysis of the different Euro classes for 3 different emission values. So CO, left, right, NOx, and in the middle is HC. And what you can see is that with dropping limits for the Euro classes, we also have a dropping CO and HC. We have an increase in the NOx and then a drop of NOx. So that's due to different technology which has been introduced. So conclusions, preliminary conclusions on the emission measurement system. So said before, we can use only selected commercially available PEMS equipment, and this is just suitable for bigger motorcycles. For smaller motorcycles, there is equipment with restricted significance possible, but it's not commercialized now. It has to be developed further, so it's not on the market at the moment. The big crux is the assessment of the exhaust mass flow. So the measurement of what comes out of the exhaust, the gas mass. This is difficult, especially for a low cylinder number, and this would be the real crux for further developments. We found out that the lab measurements, the traces are possible for lower power demands, and that means possibly we could also drive smaller vehicles on RDC cycles in the lab. So that fits because due to the lower power. For the high power vehicles, it's difficult to have a real RDC cycle in the lab. So that's about the measurement technology. And now to the emissions. Type approval versus on-road measurements. We've seen that there's a big difference between type approval emission and on-road emission levels, whereas we have to state there are no regulations at the moment for these situations on-road, but we've seen there's a difference. And we have seen there's a big difference in driving style. So whether you're doing standard driving within all the limits of the road regulations, or if you are driving more aggressively. So that makes a big difference. Type approval measurements, so the average fleet emission is well below the limit, so that's a nice output. But we have outliers, we have high emitters which are partly way over, and we have some of them which are considerably below the limits. So both is possible. And for the on-road emission, we have seen that the fleet average of L vehicles on-road emissions, it seems to be reduced in the same pace as the Euro emission limits, as we have seen on the roadside measurements. We have big difference between high emitters and low emitters, and there is a big challenge for the roadside measurement instruments to measure the LV pollutant emissions. That's mainly due to the fact that the plumb of those vehicles is very small, is low on the bottom, and so on. So this was the first results, the first output, what we found out, and I'm happy to answer your questions.
Thank you, Stefan. Perfectly on time. There are a couple of short and longer ones. Roland Berger is asking which bike was used for the RDE test.
We use standard tests, and I think we cannot at this stage we cannot really give identification of the different tests.
Okay. Additionally, I can't see his full name. Christopher is asking if there are a few outliers, wouldn't the median average be more representative than the mean average? So median versus mean average.
Yeah, that's a good input. Yes, as I said before, we are just at the beginning of the analysis, so we found out that there are outliers, and we have to think about how to deal with that. So there are different possibilities. One is to identify the outliers and maybe see why they are, and maybe exclude them from the mean or use the median average. So we are working on that. Yeah.
Joan Bernard is also, first of all, thanking us for the interesting presentation, and then it's a bit of a longer question. During the first presentation, I believe a portable noise measurement was seen. This method differs from the type approval noise test that is done on a test track in a narrow testing condition. Could you please comment on the technical feasibility of such portable noise measurements for upcoming regulations? I think
Yeah, that's a good point. So what we have done here is that we wanted to see if we could identify high emitting, noise emitting events on the bike also. So of course we have the typical type approval on the test track, but the question is, do we cover all situations? So as you might know, there are ASAP2 regulations which try to have additionally situations incorporated but covered. But the question is, can we also identify these events on the bike? And this was the idea about. But we don't know if this is feasible. You know, that's a big question.
Can I just make a comment, Stefan, here? As I said, we are still in the preliminary phase of analysis of the data. Of course, everyone understands that when we ride a motorcycle on a city network and we are recording sound, you cannot isolate just motorcycle sound. You also capture noise from the environment. So it's in principle more complicated than real drive emission testing. Nevertheless, we hope that at the end of the project, we will be in the position to give some range on how useful such a test can be. And if you remember, I showed you that we have been using a test track for this kind of measurements, not just riding within a city network. So we're also a little bit looking forward to actually find out, and we don't have the final results yet to give you a definitive answer. Thanks.
Thank you, Leonidas. Maybe a very short answer to the question from Christian Hafenmeier. What is the databases about the EFM usability challenge for mass flow determination?
Yeah, thank you for the question. So the databases is several vehicles what we have measured on the lab with a CVS measurement instrument and also with different EFM mass flow measurement systems. So we have several vehicles measured, small ones and big ones. And what we identified is that especially for the small ones where we have a low cylinder number, big pulsations, there is an issue. So that's the basically, very short, that's the database. So several vehicles measured in lab and comparison to EFM measurement systems.
There's one last question from Marco Guazzaroni. Is there any information about energy suppliers for mini PEMs or ZEMs? This could have some effect on the result.
I'm not quite sure what the question focuses on, but energy supply, I mean, we have standard battery packs for the mini PEMs and SIMs, so that the energy itself does not really affect the results. So it's independent of the motorcycle's energy.
Okay, great. Thank you for this brief answer. I will basically going to conclude now with some upcoming online events that are taking place. I've seen that you have that the audience is quite mixed. Of course, there are lots of stakeholders and OEMs and from that side, but also I've seen our friends from the LENS stakeholder group who are organizing a stakeholder workshop, which is focused on the challenges of citizens in Germany and the Netherlands related to noise, and it's called Sound of Silence ? And will take place on the 9th of April from 10 to 12. You can still register. Of course, it is less technical, but we also want to include the challenges of noise and air pollution that all these citizens, whether they live in rural areas, peri-urban or urban areas, are facing in order to highlight the problems that exist with L vehicles. And then throughout the summer, there will be a webinar on the other aspects that we have already listened to this morning regarding the in-field surveys where we talk about what was actually measured and how it was measured in the 3 venues where we did some pilot testing in Leuven, Paris, and Barcelona. And in case you're going to follow our social media and our homepage or the newsletter, you will get further information about this. On the right-hand side, you see a couple of photos during these tests. And in case you want to register directly to the stakeholder workshop, feel free to use the QR code or check our homepage. And then to wrap it up, as already mentioned before, peeking a bit into the future, we will most likely have the LENS final conference in mid-October. And if you've ever been to that area, you can identify where this is going to take place. Most likely it will be in Brussels. And there we will also present, hopefully, if everything goes right, our final brochure and then our final summaries also in written form. That means there you can find all the details and also then our policy recommendations. And with that, I'm going to conclude the webinar. And I thank all of the presenters very much and those who attended. In case there are specific questions, you can always approach our presenters or the POLIS colleagues, me and Fanny. And yeah, thank you very much and have a good day.